हेलो डियर स्टूडेंट्स. सो इन दिस सेशन वी आर विद अ न्यू टॉपिक. ठीक है ना बेटा. तो जो हमारा नया टॉपिक है दैट इज इलेक्ट्रिक डाइपोल फॉर क्लास 12. ओके, हाईली इंपॉर्टेंट फॉर क्लास 12, highly important for NEET and highly important for JEE Mains as well. All right. So first of all, what I've written down here is this is the contents of this electric dipole. Okay. So number one topic is what? That's dipole moment. Topic number 2 is electric field. Topic number 3 is subtopic number 3, that is torque and dipole, highly important. Topic number 4, that's work done, potential energy. Topic number 5 is then the simple harmonic motion of the dipole in a region of uniform electric field. Okay, so these are the topics we will be going through. Okay, we'll be discussing them one by one. Okay, it was a demand of class 12 students that this dipole electric dipole jo topic hai, we need to revise this. The reason is that there are some students who have confusions, okay, regarding this topic. So let's discuss it. Okay, so let's discuss it one by one. Okay, so first of all let's discuss what is this actually electric dipole. Okay, so let me write down here electric dipole. So we'll be starting with this electric dipole. All right, electric dipole. Now what is actually electric dipole? Simply electric dipole is defined as the system of two equal and opposite point charges. Okay, so here I will write down what I will write down like this. It is a system of two equal and opposite point charges. Two equal and opposite point charges. Equal implies same in magnitude, opposite implies that opposite point charges. Point charges. ठीक है ना बेटा? Point charges, opposite means that one is positive, another is negative. Okay, all right. Okay, so first let me define this. Let me define it here. So here we have, these are 2 point charges. For example, this is 1 point charge and this another point charge. Okay, these are 2 point charges. Let's label this as point charge minus q. Let's label this as charge plus q. Now this system, this called as dipole. As simple as that. Simply there must be a system. This system must contain how many charges? It must contain 2 charges. One must be having a charge of minus q, another having a charge of plus q. All right. Now here this is called what we call as center of dipole, point O. Okay, now this is A and this is A. Then what is this 2A called? This 2A in chemistry we call it the bond length, and here we name it as dipole length. So here let me name it as dipole length. All right, so we label it as dipole length. ठीक? Okay, great. And what about this q? This q is called as charge of dipole. This q is named as charge of dipole. Charge of dipole. Okay, तो आपको बेटा यहाँ एक point आपको पता होना चाहिए. That's like this. If for example I am saying that the electric dipole has a charge of q, what does it mean? It means that it contains 2 point charges, one having a charge of plus q, another having a charge of minus q. Otherwise the net charge of the dipole as a whole is 0. It as a whole the net charge is equal to 0. Okay, if I am for example saying, as an example I am saying that the charge of the dipole is plus 10 coulomb, it's 10 coulomb, sorry. So what does it mean? It means that it contains 2 charges, one point having a charge of plus 10 coulomb, another having a minus 10 coulomb charge. All right, okay, great, perfect. ठीक. Now here I am going to define a physical quantity, and that physical quantity is what we call as dipole moment. Dipole moment. Okay, and an important term here. So let me write it down here. So important term here is dipole moment. Okay, dipole moment. It's a vector quantity and is denoted by P. थोड़ा सा आपने केमिस्ट्री में पढ़ा होगा in chemical bonding, dipole moment. ठीक है ना बेटा? So how we define electric dipole moment? Simply electric dipole moment is a physical quantity which is equal to the product of the charge and the dipole length. Okay, so for example here we have this the dipole, this is a charge minus q, and this charge here this equal to plus q, and this is the center of the dipole, point O. This is A, this is A. So what is the charge of the dipole? That's q. And what's the dipole length? That's twice A. Okay, we can take the dipole length as A. Why we take the dipole length as twice A? It is simply for mathematical convenience. Later on we will calculate the electrostatic field due to the dipole on the axial line, on the equatorial line. There you will see that why we take this dipole length as twice A and why not A. Otherwise safely you can take the dipole length as A, or you can take the dipole length as R. It is purely your choice. All right, now why we then write it as twice A? The reason is simply a mathematical convenience. Okay, later on I will explain it again. Okay, so here we have a physical quantity, and that physical quantity is what called, that's called as dipole moment. This dipole moment is first of all a vector quantity and is directed from minus q to plus q. denoted by P vector. Okay, now what is this P vector equal to? So here I will write it down. This P vector is simply equal to charge of dipole, and that's equal to Q multiplied by dipole length, and that's equal to twice A. Okay, all right, simply what the charge of the dipole, that's equal to Q. What is the dipole length? That's equal to A plus A, so that's equal to twice A. So dipole moment here, and again there is a reason why we label, why we name this as dipole moment number one, and why we define it. Okay, the reason is this: later on what we'll be doing is that we'll be putting this electric dipole in a region of uniform electric field. Then this torque, this dipole will experience a torque, and when we'll calculate the torque, you will see that the torque of the dipole depends upon two parameters of the dipole, and number one is charge of the dipole, number second is that the dipole length. So these two physical quantities, that is charge and the dipole length, they actually define, they are a measure of the dipole moment on the dipole when placed in a region of uniform electric field. Again, we will later on calculate the torque, you will see it. Okay, the equation will be something like this. Later on when we'll calculate this torque, the equation will be something like this. It will be Q multiplied by twice A multiplied by E multiplied by sine theta. Okay, later on we'll calculate this. Okay, now you see that in this very expression, when we'll derive this, you see that in this expression it contains this Q multiplied by twice A. All right, now this both Q and twice A, they are the properties of dipole. One is the charge of dipole, another the length of dipole. So that means this is the measure of torque. More the value of this Q multiplied by twice A, more is the torque experience of the dipole, and vice versa. So then collectively, combinedly, we'll name this term as a dipole moment. We name it as dipole moment. Okay, the reason is that it's a measure of torque. All right, okay, take it a bit. Okay, so this is P is equal to Q multiplied twice A, always directed from minus Q to plus Q. ठीक. Okay, next, अब यहाँ ध्यान दीजिए बेटा. Next, what we have to write down is this: what are the units and dimensions of P? Okay, so P is there. What is in turn equal? It's equal to Q multiplied by twice A in magnitude wise. So what will be its SI unit? SI unit will be simply coulomb meter. What about dimensional formula? That will be A1, T1, and L1. All right, A1, T1, and L1. Or you can write it like this: dimensional formula is M0, L1, T1, A1. This is the dimensional formula. Okay, and directed from, since it's a vector quantity, so it is directed from minus Q to plus Q. Okay, its value is equal to Q multiplied by twice A, number one. Number second is the vector quantity directed from minus Q to plus Q. Number third is that its units and dimensions, coulomb meter, and then this M0, L1, T1, A1. All right, so we define the dipole moment. Okay, then some important point here. Okay, so another important point here is this, that all the molecules are classified into two categories. One we called as polar molecules, another we called as non-polar molecules. Okay, so one we label as polar molecules. Now how we name it is, how we define polar molecules. So we say that polar molecules are those molecules for which the net dipole moment is non-zero. This net dipole moment, it is not equal to zero. And what about the non-polar molecules? So this question has been asked as such in the NEET 2020. NEET 2020. There cannot be a simplest question than this, that what are polar molecules? Polar molecules are those molecules whose net dipole moment is, polar molecules are those whose net dipole moment is not equal to zero. Then what about non-polar molecules? How we define non-polar molecules? So non-polar molecules are those molecules for which the dipole moment is equal to zero. So they are non-polar. Okay, for which the dipole moment is equal to zero, they are called as non-polar molecules. Then you have huge number of examples from the chemistry. You know that the polar molecules are there, like HCl is a polar molecule, NaCl is a polar molecule, isn't it? NH3 is a polar molecule, water is a polar molecule. Then there are some examples of non-polar molecules, like for example, there are some like H2 is there, N2 is there, O2 is there, CH4 is there, C2H2 is there, and so on and so forth. Okay, so then you know there are different types of what polar molecules and non-polar molecules. Simply in one line definition of the polar molecules, that whose dipole moment is not equal to zero, and non-polar are those whose net dipole moment is equal to zero. Here net dipole moment is non-zero, and here it is equal to zero. All right, okay, next is that we are supposed to calculate the electrostatic field due to a dipole on the axial line and on the equatorial line. So let me write it down here. So जो हमारा नया टॉपिक है बेटा वो ये है that we are supposed to calculate what? We have to calculate electric field due to dipole. Electric field due to dipole. Okay, so we have to calculate electrostatic field due to dipole at 3 different positions. Number 1 what we call as equatorial line, number 2 what we call as axial line, and number 3 is there what we call as generalized position. Okay, so A will be starting with this. A is the equatorial line. On equatorial line we have to calculate the electrostatic field. All right, so let me calculate electrostatic field on the equatorial line. Okay, so first of all let me explain it to you. What is an equatorial line? So for example here we have this an electric dipole. यहाँ आप ध्यान दीजिए बेटा. So this is an electric dipole. This charge is minus q, and this another charge particle which is plus q, and this is the center point. So that's point O, and this is A. This is A. All right. So what we can write, first of all, point number 1 is this, that this dipole moment is equal to q multiplied by twice A. All right. ठीक है ना बेटा? So this dipole moment. Let me first of all write down here that this dipole moment is what? That's equal to q multiplied by twice A. Where twice is the length and q is the charge of the dipole. Okay, now we are supposed to calculate electrostatic field somewhere here on this very line and this line, which is the perpendicular bisector to what? Which is the perpendicular bisector. Wait a moment. So here we have, for example, this is the line here. This is the perpendicular bisector to the dipole. Okay, perpendicular bisector to dipole. At this very point, this is point P. We are supposed to calculate electrostatic field at the point P. This OP line is called as equatorial line. Equatorial line implies that line which is perpendicular bisector to the dipole. All right. Then this distance is given to us. This is equal to R. And what we have to calculate is electrostatic field at which point? At point P. Obviously, okay. So now the question arises here: how many electric fields will be there at the point P? Or electrostatic field at the point P will be because of how many charges? तो आपका आंसर आएगा बेटा electrostatic field at point P will be obviously because of how many charges? Because of 2 charges. Because there are obviously 2 charges. So one because of minus q, then because of plus q. ठीक है ना बेटा? Point number 1. Point number 2, what is the electrostatic field because of this charge q? That is simply k multiplied by charge divided by distance square, isn't it? K multiplied by charge divided by distance square. Point number 3, then the electrostatic field because of minus q will be attractive in nature. It will be directed towards minus q, and the electrostatic field because of plus q will be repulsive in nature. That will be directed away from plus q. All right. Okay. So let me do one thing, and that is I will complete this triangle here. Okay. I will complete this triangle here. All right. So we have completed this triangle. Wait a moment. Let me redraw this diagram here. Let me redraw this diagram here. Okay, so here we have, this is the equatorial line. Okay, now these are 2 lines, more 2 lines like this. ठीक है ना बेटा? Okay, now for example, let's label this as angle theta, and let's label this as angle theta. Now this is r, and you can use the PGT, Pythagoras theorem. So obviously this distance, ये distance कितना आएगा बेटा? It will be equal to root of r square plus a square. What about this distance? What about this distance? ये भी होगा कितना? R square plus a square. ठीक है ना बेटा? Okay, now this point P, क्या है बेटा ये? This is point P. All right. So at point P, how many electric fields will be there? Obviously there will be 2 electric fields. One because of minus q, another because of plus q. So because of minus q, it will be attractive in nature. It will be attractive in nature. Let me show it like this. So it will be attractive in nature because of this. So in this direction it will be E, and then because of plus q, it will be like this along this very direction, and this here plus E. ठीक है ना बेटा? Because of plus q, it will be repulsive in nature. Okay. All right. The next what I will do is this. ये angle हमारे पास theta है बेटा. So that means this angle will be theta because alternate angles. This angle is theta, तो ये theta होगा because corresponding angles. All right. ठीक है ना बेटा? Okay. So how many electric fields we have? We have 2 electrostatic fields, E and E. Why I label this as E and this as E? Because their magnitude will be exactly same. The reason is that जो ये point P है बेटा, it is equidistant from minus q and from plus q. So that is why the electrostatic field because of plus q, because of minus q, magnitude wise it will be same. All right. Okay. Next what I'm going to do is that I will resolve this E into the rectangular components. इसके 2 components होंगे बेटा. इस दिशा में एक component होगा that will be equal to E cos theta. Okay. Then there is one more component along this direction that will be equal to E sin theta. ठीक है ना बेटा? Like this it is in this direction. इस E के 2 components होंगे बेटा. जहां थीटा वहां cos, तो इस दिशा में एक कंपोनेंट आएगा E cos theta. E cos theta plus E cos theta will be equal 2 times E cos theta. इसका एक कंपोनेंट इस डायरेक्शन में आएगा बेटा, and that will be equal to E sin theta. That will be equal to E sin theta. Now you see that this E sin theta is going to cancel with this E sin theta. The 2 E sin thetas will cancel, and we are left with what? E cos theta plus E cos theta will be equal to 2 times E cos theta. So the electrostatic field, let me write it down here. Let me write it down here. What is the electrostatic field at the point P now? Electrostatic field at the point P will be simply equal to 2 times E multiplied by cos theta. ठीक है ना बेटा? Twice E multiplied by cos theta. So first of all, what I will do is this. I will write down here what's the value of cos theta. I will calculate that geometrically. Cos का किसके बराबर होता है बेटा? Cos का होता है बेटा base divided by hypotenuse. All right. किसके बराबर होता है बेटा? Base divided by hypotenuse. Okay. अब यहाँ ध्यान रखो बेटा, base divided by hypotenuse. Now in this very triangle, what is base? That's obviously equal to A. And what about hypotenuse? That is equal to root of r square plus a square, which we have calculated by using Pythagoras theorem. ठीक है ना बेटा? Okay, so we have calculated cos theta as well. So let's work out the value of the E. And what is this E? E is the electrostatic field because of my point charge. ठीक है ना बेटा? So here let me write it down. First of all, let me write it down here. So here what I will write down is this. First of all, what is the cos theta? What is the value of cos theta? Let me rewrite it here. तो cos हमारा किसके बराबर है? That's equal to A divided by root of r square plus a square, isn't it? Or A divided by root of r square plus a square. Then let me write down the E electrostatic field. That will be equal to K multiplied by charges Q divided by यहाँ आप ध्यान दीजिए बेटा. So E is the electrostatic field because of this point charge. That's equal to K multiplied by Q divided by distance square. And what's the distance between this point P and this charge Q? That is obviously this distance, which is equal to root of r square plus a square. ठीक है ना बेटा? Okay, so let's write it down here. यहाँ हम लिखेंगे बेटा that's equal to root of r square plus a square whole square, isn't it? So that's equal to a whole square. So that will be equal to K multiplied by Q divided by the square and root will cancel. It will be here something like this, r square plus a square. ठीक है ना बेटा? Okay, I'm sure you are following me. Concentrate here. अब यहाँ ध्यान दीजिए बेटा. So next हमें क्या निकालना बेटा? Next is electrostatic field on the axial line. That's equal to 2 multiplied by E multiplied by cos theta. Sorry बेटा, ये axial line नहीं है बेटा. This equatorial line. Okay. So let me name it as EE, where E stands for the equatorial line. All right. Okay. So let's substitute the values now. So 2 multiplied by E के बदले क्या लिखेंगे बेटा? E के बदले हम लिखेंगे KQ divided by r square plus a square. Isn't it? Multiplied by what about cos theta? बोलो बेटा cos theta के बदले क्या लिखेंगे? A divided by root of r square plus a square. Root of r square plus a square. Okay. Let's move ahead. Now the electrostatic field on the equatorial line is equal to, it will be something like this, 2K Q into A divided by, ठीक है ना बेटा? 2K A Q into A. Then the bases are same. So in multiplication, when bases are same, powers must be added. तो इसका power है बेटा 1 और इसका power है बेटा 1 by 2. So it will be something like this. It will be r square plus a square. When bases are same, powers must be added. So it is 1 plus 1 divided by 2. All right. तो यहाँ ध्यान दीजिए बेटा. So it will be something like this, twice K Q into A divided by r square plus a square raised to the power 3 by 2. Because 1 plus 1 by 2 is simply 3 by 2. So this is the electrostatic field on the axial line. So it will be something like this. KQ twice KQA divided by r square plus a square is about 3 by 2. Next, what I am going to do is this. I am going to substitute the value of the P. अब P किसके बराबर होता है बेटा? Q multiplied by twice A. So can I write it like this? It is K multiplied by Q into twice A. Can I write it like this? Yes, of course I can write it like this. Then divided by r square plus a square raised to the power 3 by 2. So this here electrostatic field on the equatorial line. Now you see that this Q multiplied by twice A is equal to P. So final equation will be simply like this, K into P divided by r square plus a square raised to the power 3 by 2. All right. So this is our electrostatic field on the equatorial line. And we are done with this. We have derived the equation for the electrostatic field on the equatorial line. Okay. Simply what we have done is this. We have calculated the electrostatic field on the equatorial line because of 2 point charges, that is plus Q minus Q. Then we have taken the vector sum of them. Okay. We have resolved E in the rectangular components. The cos components Wallace will add, and the sin components will simply subtract. They will cancel. So the net electrostatic field will be simply equal to twice E cos theta. Substitute the value of cos geometrically, and substitute the value of the E using Coulomb's law. That's electrostatic field due to a point charge is equal to kq divided by distance square. The distance there was what? That was root of r square plus a square. All right, okay. So let me do one more thing, and that is I will write down this equation here. So the electrostatic field on the equatorial line is simply equal to what? That's equal to k into p divided by r square plus a square raised to the power 3 by 2. Okay. Now next what I will write down is that in the vector form I will write it down. In the vector form I will write it down. In order to write it down in the vector form, we have to go back the diagram. So you see the diagram. Okay. Now you see that this electrostatic field, it is directed towards left. This is the electrostatic field, and the dipole moment that is directed towards right, isn't it? Because dipole moment is directed from minus q to plus q, and the electrostatic field is directed towards left. अगर हमारे पास बेटा यहाँ पे क्वेश्चन होगा बेटा, this is the electrostatic field on the equatorial line. What is the angle between the electrostatic field on the equatorial line and the dipole moment? तो आपका आंसर सीधे ये होगा बेटा, the answer will be 180 degree because they are anti-parallel. If the dipole moment is towards right, the electrostatic field will be towards left. If the dipole moment is towards left, the electrostatic field on the equatorial line will be towards right. All right, okay. So finally, this is what I will write down here. So the vector form, I can simply write it like this. Electrostatic field on the equatorial line is like this. It is equal to something minus k into p, where negative sign implies direction reversal, implies that this electrostatic field and the dipole moment are anti-parallel. Okay, so this is the electrostatic field. All right, okay. Then here we have a special case to discuss. Okay, we want to discuss a special case, and that special case is what? Short dipole. What will be the electrostatic field for the short dipole? Okay, so let's calculate that out. So here I will write it. Let me write it down. Special case. So the special case here which we want to discuss is that for the short dipole. For the short dipole, what will be the electrostatic field? All right, okay. So let me write down the electrostatic field for the short dipole. What short dipole means is this. यहाँ आप ध्यान दीजिए बेटा. So short dipole simply implies that if the length of the dipole is very small compared to this distance r. For example, the dipole length ordinarily for a dipole is in the order of angstroms, and this r, for example, it is few centimeters. Then obviously this few centimeters is very large compared to the angstrom. So safely what you can do is this. Okay, so let me write it down here. It means that this a is very small compared to r. So this in turn implies that this r square plus a square is approximately equal to r square, because we can safely neglect the a square compared to the r square. Then what this equation will become is this: electrostatic field on the equatorial line is equal to, it will be something like this, k multiplied by p divided by r square plus a square is approximately equal to r square whole raised to the power 3 by 2. This 2 is going to cancel with 2. So what we are left with is this kp divided by r cube. Okay, so electrostatic field on the equatorial line for the short dipole is equal to kp divided by r cube, and that too anti-parallel in direction. Fine. Here we have an important point. And that important point is like this, that electrostatic field due to the dipole is proportional to 1 divided by r cube. ठीक है ना बेटा, ये आपको याद होना चाहिए बेटा, ये वाला point, that electrostatic field due to the point charge is proportional to 1 by r square, and electrostatic field due to the dipole is proportional to 1 divided by r cube. Okay, so that means as the distance increases, the electric field dies down, it decreases both due to the point charge, it decreases due to the dipole as well, but it decreases more rapidly due to the dipole compared to that due to the point charge. All right, okay. So this question has been asked directly in AIPMT. Okay, you can check the DPP sheet.